Welcome everybody. I will talk about the Master in Quantum Science and Technology offered by the Basque Country University and more specifically by the Faculty of Science and Technology. So we'll have Schrodinger's cat watching all the time. Okay, this is the Faculty of Science and Technology in the University of the Basque Country. It's located in this place in Leioa, which is very near Bilbao. Okay, so here you have the map. I hope that you can see where this is. I mean, this is Spain, so this is the Basque Country. Actually, it's an autonomous community within Spain. Okay, so this is a broader view where you can locate the place. We are here. And let me first of all talk a little bit about the Basque Country University to give some data. So it's the public university of this autonomous community. It's a 30-year-old institution. It's a big university with 45,000 students and 3 campuses. Corresponding to the 3 capital cities in this community: Bilbao, San Sebastian, and Vitoria. We have about 5,000 academic staff and state-of-the-art facilities. Regarding physics, we are classified between the 200 and 300 in the Shanghai University ranking classification. So, okay, what's the essence of this master? The essence is that we provide academic training in quantum physics. And this training is oriented towards research, clearly. So our students will, after the master, get involved in some sort of doctoral program, PhD program. Okay. Why is quantum physics interesting? Well, there are quite a number of reasons. First of all, it's a central theory to understand the world, from subatomic particles to cosmology. In between, you have atoms, molecules, and solids. So it's a very fundamental science to understand the world from a physics point of view. Not only that, quantum physics also shapes our society from the point of view of technology. The most important inventions in the 20th century are the transistor and the laser. The transistor supports the whole industry of microelectronics, so the mobile phone, the computers couldn't work without quantum mechanics. The laser has, of course, many applications, in particular in communications, in fiber optic communications. And actually, at this point, quantum physics is also important because new opportunities are open in different places in quantum information processing to develop new sensors, secure communications, or metrology. People talk about the second quantum revolution. Why? Because we are learning how to tame a number of properties such as entanglement or superpositions in new ways. So, of course, governments and companies, big companies like Google or IBM, are getting interested, and there's a lot of investment by both governments and companies in quantum research. Okay, we have our own history. This master is active since 2011, which is quite a long time for most of the masters in this field. Certainly, we've been the only master in Spain specifically devoted to quantum science for all these years, and one of the few, I must say, in Europe. No, of course, now there are more emerging. In this master, we think of graduates in physics mostly, obviously, but we would also consider students such as engineers or chemists with some background in quantum mechanics. I will give you some additional information. For example, we take about 20 students every year. The teaching mode of the master is face-to-face, but considering the times we are living at this point, we are ready to go online, actually, if necessary. Actually, we had to do this last March. We had to go online for 2 or 3 months. Okay, so at this point, right now we are teaching face-to-face, but of course things change rapidly, so we are ready to go online at any time. The language we use in the master is English, so it's the official teaching language of the master. This is a 60 credits master. Okay, this is jargon. It's a European way to measure the work hours by the student. But okay, that boils down to actually one academic. You can translate it to one academic year. So that's the duration, 1 year. The fee is quite reasonable, 2,300 euro. And well, summing the teachers in the different courses and the researchers involved in research projects, we are nearly 60 people. So it's quite a large number of people. Okay, here is the structure of the master. So we divide it into 3 trimesters. In the first trimester, we have the compulsory courses, 4 compulsory courses. We'll see later the actual names. So this takes 3 months. Then the next 3 months from January to March, we have the optional courses. The student has to choose 5 courses. And the rest is devoted to a research project. This is very important for us, the research project, and actually I would say it's the hallmark of the master. So what's the idea? The idea is that the student gets involved in real research with a group, with an active group doing research in quantum physics. And the typical result of this is a paper. It's a scientific paper. It must be original work. And apart from the master thesis, as I said, we typically will produce a paper published in some of the good physics journals. There are 2 possible career paths in this master. We call one of them fundamental physics. That would include gravitation, cosmology, condensed matter, or quantum field theory. And the second line is quantum information and technology. Actually, the student can make a superposition. So the student could choose among the different lines. So here is in more detail the syllabus. For example, these are the mandatory subjects or compulsory courses in the first trimester. So advanced quantum mechanics, quantum field theory, quantum optics and information, and quantum statistical physics and condensed matter. And then the student chooses in this list 5 topics for the second trimester. You see that there are some of them correspond to the first line, to fundamental physics. The others correspond to quantum information or quantum technologies. For example, well, this is specifically quantum information, quantum technologies, advanced quantum optics, cold matter physics, and so on. No? In the other line, for example, they could choose quantum aspects of cosmology, superstrings, etc. Okay, as for the research project, well, there is a broad set of fields, of topics. And to be more specific, let me show you, for example, this is the list of projects offered in the fundamental physics line this year, 2020. So you can have a quick look at some of the titles of the topics offered. And this is for the fundamental physics line. And okay, here we have a bigger list for the other line for quantum information or technologies. So here you have a broad set of topics, I don't know, from quantum state tomography to quantum control, quantum measurement, quantum computing, of course, quantum thermodynamics, and many other topics. No? So these are all active groups. The directors are all active groups. You will see that the names of the directors, of the advisors, don't look very Basque or very Spanish, many of them. And the reason is that, okay, they have been hired through a program called Basque. Basque is the Basque Foundation for Science. The Basque has been hiring international researchers consistently for the last 12 years or so, or even more. And okay, so we have benefited greatly from this initiative. And the result is that we have a very dense and strong network in quantum physics in the Basque Country University. Okay, let me tell you a few things about Bilbao. So Bilbao is a vibrant city in the north of Spain, about between 500,000 to 1 million population, depending on how you count. We are relatively well known these days because of the Guggenheim, this wonderful piece of architecture by Frank Gehry. Bilbao is surrounded by mountains, so there are many hiking possibilities. We are also near the sea, so you can also enjoy the sea in different ways. And well, in the Basque Country, we are well known because we like to eat well. So in particular, and you don't have to spend a lot of money. You can eat tapas in a bar. The tapa is a kind of snack. The idea is that you go to the bar, eat one tapa, drink a little beer, and then, well, you can iterate that many times in different bars, okay? So that's an interesting tradition we have here. Well, coming back to practical stuff, so about the connectivity. Well, Bilbao is very well connected. The airport has direct flights to all the main European capitals and hubs. Okay, so these are direct flights from Bilbao. We have a metro with 3 lines. One of the lines takes you to the sea. You can go easily. Unfortunately, okay, the metro doesn't take you to the university. This is a map of Bilbao and the surrounding area. The university is located here. So the way to get here from the center is by bus. There is a reasonable network of buses that connect different points in Bilbao with the university. Okay, and basically that's it. We'll finish by giving you some contact information. Well, there is a web page where you can find more details about anything I've just said. Okay, so that's all. If you have any question, I'd be happy to answer. I guess I have to stop sharing the screen, Taril. That's.
You could leave it on while we talk.
Oh, okay.
Just give people time to write things down, etc. Thank you, Gonzalo. Oh, now you don't need to share it anymore.
Well, it's.
Oh, there it is. Okay.
To remind you that I'm here. Yeah.
Okay.
Yeah, I'll put I'll put the web page. Okay.
Oh.
So this is the web page. It's in English, and so yeah, you can see the actual web page. This is me, by the way. There is a little video and some more information, no? Teaching staff, registration procedure, etc.
Wonderful. Any questions from anyone out there? Now's your chance. So, Abir?
Yeah.
Please.
First of all, great presentation. Thanks for the information. And I just had one question regarding, I am actually pursuing my major in computer science. So is there any specific requirement as of like, I need to pursue some physics courses or specifically on quantum mechanics or something?
Yeah,
Or,
exactly. Yes. Yeah, we would like you to have some course in quantum mechanics, basically. That's the requirement. So it's okay if you're a chemist, engineer, whatever, no, as long as you have some training in quantum mechanics. Yeah. I mean, in the past, we took people without quantum mechanics, but it was, I mean, we realized that you need some homogeneity, it was very difficult to keep the group together with very different backgrounds. So a minimum would be some knowledge of quantum mechanics, and if possible, through some academic study, Yeah.
so actually in India it's basically called as engineering physics, and it includes some basic quantum mechanics and like time independent Schrodinger equation and all those things. So will that
Okay.
be enough, or
I see.
do I
So
need
it's
to go in
just
more
part,
depth?
So
Yeah,
that would be
it's not
part of a bigger
part of
course.
the, yeah, exactly, yeah.
And
So
yeah, how much? I mean, is it half of the
uh,
course or
let's say 1/3 or
one
something.
third? I see. Yeah, well, you would be in the edge. It's okay. We would have to discuss that, I think.
Okay.
Yeah, we would have to
Okay.
discuss that case. Yeah, and look at it in detail. Yeah, uh,
Thank you.
yeah, yeah.
If I may add, Gonzalo, and for everybody, and you tell me. Of course, every situation is different, but at the master's level, it's less of a hardcore or an immediate line in the sand. So I would think if I were an undergrad, for example, and I had a year to beef up my quantum mechanics, and could take some of the MOOC courses or what have you, and demonstrate to whoever the admissions decision people are, I would think that would suffice in that, I think that, would this be correct? I mean, the idea is that you want to have people that are starting the program with a certain level of knowledge, and how you got that knowledge is less important than having that knowledge. Would that be fair to
Sure.
say?
It is fair to say, yeah, but it's also fair to say that it's not so easy to get a basic knowledge of quantum mechanics without having passed through a course in quantum mechanics, no? Yeah, and yeah, you see, we have 20 positions. We admit
Yeah.
20 students at this point. And for example, last year we had more than 60 applications, you see. And well, many of these people were physicists. So yeah, it's difficult to get someone who is not a physicist in these circumstances and considering these numbers. No? So it may happen. Perhaps if someone is very motivated, the background is appropriate, and the motivation is a good one. Okay, we may of course consider that as a possibility. But I must also admit that it is not so easy if you think in terms of 60 applications and 20 positions. No?
Yeah, that's a good point. When you
Yeah,
look at and that's one of the reasons for this master's initiative here, is to really get a sense of how many seats there are out
yeah,
there
yeah.
globally. And if you think about it, my guesstimate is somewhere around maybe 200. So, especially this early day in master's programs, I would imagine competition in many of the programs is quite tough.
Mhm.
That's a good point.
Yeah. We
But
at this point we don't want to grow. Maybe in the future, maybe in a couple of years, we might think of it. But at this point, we don't want to grow too much because for us, this research project is very important. So that means we have to have people ready to carry on this research with the students. And okay, that takes a lot of effort and time and energy. So yeah, I mean, growing to large numbers, if you want to be very close to the student as we are, it's not so easy.
Yeah. I have a couple questions in the chat just quickly. Do you know, is there a GRE in physics required?
GRE, sorry, I'm not aware of that acronym. What does it mean, GRE?
General
Relativity?
General something equivalent, no. Well, if you're not familiar with it, then no, I guess it's not required. We could just take that.
No.
Oh, that's right. The graduate record examination. Thank you. It's commonly used in the United States. I'm not sure about Europe.
I see. No, I haven't heard of it. I don't know what that is, so don't worry.
Okay. Fair to say. Is there a scholarship that covers the university fees?
No, not in principle, unfortunately. No, but the price is, I must say, very reasonable.
Indeed.
I guess yes. I mean, compared to other fees around, it is very, very reasonable.
You just have to add a few dollars for or a few euros for that tapas iteration.
Sure. Make sure to save some euros for the tapas.
Yeah. That's a variable cost. Lastly, and then we'll move on. Do you have an idea roughly what the deadline is for applying? What's your application cycle look like? Yeah, it's usually done. Everything is usually done in a rush in September. Okay. September. So, but yeah, I mean, September is the very deadline. But of course, you should try to do it earlier. So you can see the details here. In registration, but of course try to do a pre-registration earlier, even before summer. Okay, but then there is always some motion, people that initially thought that would come and later don't come, and so on. So the final set of students is decided in September. Okay, but try to be early, of course. Terrific. Thank you. And if I remember, Jose, is it Jose who's the contact person, which was on that slide earlier? I'll put that on. Yeah. Okay.
Right. Yeah. There you have it.
Was it Jose? Yeah. Terrific. Okay. Gonzalo, thank you very much. Much appreciated. Thank you for the education.
Thank you very much.
And I'll be investigating plane tickets to your area because I do want to stop by and say hello someday.
Great. Okay. You're welcome.
Okay.
So
thank you. Feel free to drop off. Bye-bye. You got to get back to work and much appreciated.
Okay. Thank you so much.